All right, so this lesson is Foundations of Math in Pre-Calculus 10, Section 5.2, Properties of Functions. So we had talked earlier in the last lesson about relations, and these are some of the notes that we went through. We expressed and showed how two quantities can be related to each other. We talked about people being related. We talked about things like fruits and their colors being related. And we talked about these things in terms of relations. We talked about many different ways to represent these relations, graphs, ordered pairs, and that sort of thing, and charts and tables. And in this lesson, we're going to talk about a special type of relation called a function. Now, if you look at this set A and set B here, we have fruits and we have colors. Now, if we draw an arrow diagram, we know that an apple can be red. An apple can also be green. A pear can be green, and an orange is orange. So that's what our arrow diagram might look like. Now, what is a function? Well, a function is a special type of relation where each element, that is, each item in the first set, set A, has exactly one element associated with it in set B. Now this over here is an example. Now is this an example of a function, or is this a non-example of a function? So is this not a function, or is it a function? Well, let's go back to our definition. A function is a special relation where each element in set A has exactly one element associated with it in the other set. So exactly means no more and no less than one. We look over here, the apple has two possible colors here. And so this one is not a function. So not a function here. You'll see me abbreviate functions fxn sometimes. This is not a function. Why? Because this element in set A has two pairs. Has two elements in set B associated with it. So it's not a function. Here's an example of a function. Let's test it out. A horse has or gives birth to a foal. A cow gives birth to a calf, and a pig gives birth to a piglet. Okay, this was an example from some of my students. Okay, it was very good. Now, if we look at this, each element in set A has exactly one element associated with it in set B. So there's only one arrow coming from each one, not two, or three, or four. Just one from each. So this is an example of a function for sure. All right, special type of relation. Now, you may not understand why this is important. Okay, why are we learning about functions? Well, in grade 11 and 12 math, pre-calculus, especially calculus, and in other foundations in math, you will find that we deal a lot with functions. They are special relations, and functions have a lot of purpose, and they have a lot of usefulness, and functions are very important to recognize, but also to eventually use. So I'm going to talk to you about some other properties of functions. And right here you see on the list domain, and range. And in high school, I've found over my years of teaching that students have a real hard time knowing what domain and range are. I don't know why. Really, it's not too difficult, but when you mention domain in a question, oftentimes they don't know what to do. They don't know what it's referring to. So the domain, and you'll find out in this lesson that it's not super straightforward, but I'm going to try my best to explain what the domain and range is. So the elements in set A is the domain. So really the first set that we start with, the first quantity. It's also called, the domain is also called the input variable. All right. So it's always, if you look at it this way, arrow diagram, it's always set A, the one on the left. Notice how the arrows go from left to right. So you start with an element in A, and you have some other variable that's associated with it. So this is what you start with. It's the independent variable, another way of putting it. Okay? So it's the independent variable, it's the input variable into the relation, okay, the domain. If we're talking about ordered pairs, Okay, like x and y, you know, ordered pairs like this. Like, for example, this one would be 3, 4. Okay, the x is the domain always. So you'll see x associated with domain a lot in math. But that's where you start. Now listen, normally x, y, right? The first coordinate is left or right. So that's your x coordinate. You go either left or right. In this case, we go right 3. Then we go up 4. So you start with this one, domain. The range is the elements in the second set. They are the resulting, okay, the output. Okay, if you have an input as domain, your output is your range. It's also good to think of it as the measured quantity. Okay, so we're talking about people and their height. Well, you start with a person and you measure his height. You start with another, you take another person, measure her height. Okay, it's the measured quantity. It's also called the dependent. We have independent, you start with dependent. This one depends upon the first one. Okay, so recognizing what domain and range are, and for some relations, the domain and the range is tough to identify without having a lot of information. And for some relations, it doesn't matter which is which. But there are many cases in math where the domain and the range are it's very important that you understand the difference between the two and you can identify them. If you're graphing something and you get your domain and your range mixed up, your graph will look totally different than it should, and this sort of thing. Okay, so as we move on, my next example here, I want to show you this relation right here, y equals 3x plus 2. And I asked my students when I did this lesson with them, what does this look like? What is this? They didn't have much of an answer. So what we did was we generated some points. And of course, we made a table of values. Does this look familiar? From the last section, we talked about a table or a chart is one way of displaying a relation. So x and y, notice we have x, y. This relation explains how y is explained in terms of x. So any y value is defined by taking 3 and multiplying it by the x value, then adding 2. Okay, that's how they're related. This is the mathematical description of how they're related. If we want to find out what y is, you start with an x, and you put it in here. So I start off with 2. Notice I started with x, I inputted it into the equation, and then the result, or the dependent, or the output variable, was the y. So 2, and we just show this real quickly, 3 times 2 plus 2 is 6 plus 2 is 8. So y equals 8 when x equals 2. Now that is something that you should know how to do, and you should say, yeah, that makes sense, that totally makes sense. You put 2 in there, and you get 8 out. Awesome. So this is the domain, okay? Domain. This is the range. Input, output. Now, could you have put a number in here and then figured out the x? Well, yes, but this is not really an input, right? Okay, so if I put y into the equation, what do I get? I can't really do anything to y because it's all by itself. You see? If you put x in, well, there's this little relation machine that you put x into, and it gurgles and spurts and smokes, and it kicks out a y. See? Now, this is a special type of relation called a function, because for each value of x, you get one y value, and for each value of x, you get a different y value. Make sense? So this is a function, and I generated a few points here, and we put the points on here, and this is a straight line. If you were to put more points on there and actually, draw this accurately, it would be a straight line. Okay? So this is called a linear, or linear function. And when I asked my students, what is this? I was hoping that some of them might say, or might be able to figure out that, hey, this is a series of points that forms a line. And some of them might even know that it was a linear relation, but a linear function. Okay? So a little bit more expansion on domain and range. Now, how do you tell if something is a function given ordered pairs? So we talked about that as well. If you have a list of ordered pairs, a function would not have two pairs with the same x value. Okay, so if you have a list of points and 2 points end up having the exact same x value with different y values, that's the same as drawing an arrow diagram like this, where we have 1, 2, and 3, and we have 2, 3, 4, 6 over here. You see that? X, Y. And 1 goes with 2, 2 goes with 3, and 2 goes with 4, and 3 goes with 6. Whoa, we got an issue, not a function. So how do we recognize that? If we have 2 or more points that have the same x value but different y values. So not a function. Also, it's a little bit of an aside here, but it's important also to know that in a function, 2 elements in the domain can have the same element in the range. That's close to being similar, but it's not. So you look at, I have points where all of the x values that are listed, 1, 2, and 3, all have the same y value. See how that works? And this is okay, because the only thing we're looking at is the number of arrows coming out of the domain elements. 1 from each, that's all we need. It's good. Okay? So there's a little bit about function. It's a special relation. How does it look in ordered pairs? All right? We're going to talk a little bit more about what the graph looks like for a function. It's not yet. I'm going to talk more about that. Domain and range, big deal. Okay? The second part of this lesson here is called function notation. Okay, so there's a special way to notate a function, and it's called function notation. So this is the way I laid it out. If a relation is a function, we can use function notation to express that relation, that special relationship. So if y equals 3x plus 2, we know that this is a function of x. So y here is a function of x, because no matter what x value you put in, you'll get a different y value. Got it? Which means that y equals this right here, and this is function notation. Y is a function of x. And you'll see this in the textbooks as sort of an italicized, lowercase f there. Function of x, and that's how we say it. We say it as function of x. Okay, so y is a function of x. The of is important, of. Function of x. So you can write it like this with 2 variables. So this is 2 variables, x and y. And this is function notation of the same thing. Okay, function notation. It's a function of x. Now, the reason why this is nice is because we can see this and we can communicate when we write it in this notation. It allows us to communicate both the domain and the range values in one mathematical statement. You may not think that's important, but it will be more and more important as you move through math. So f of x equals 3x plus 2. And this was the example I gave here. Okay? If we have a function equaling 3x plus 2, and I want to know what the function value is if x equals 4. Well, in function notation, do you see how I'm substituting over here 4 in for x? So guess what? I write it like this. F of x becomes f of 4. This is my input value. If this is my input value, where do I put it in? Well, I put it in for x, right here. And so f of 4 is the same as 3 times 4 plus 2. F of 4 is 14. This is your x value, or the domain element, and this is your y value, or the range element. So you can see the ordered pair is in this notation. Okay? You see the input and the output variable. Without it, if x equals 4, you'd say, well, y equals 3 times 4 plus 2, so y equals, 14. Okay, y equals 14. What was x again? Oh yeah, over here. Remember, I had to say x was 4. So you see 2 different spots. Here, just one statement. All right there. One final thing I want to say in this lesson here is writing things in function notation. Let's say you have something like this. The cost of, well, I don't know, what do we want to make it? Cost of making a dress, okay? And let's say you're looking for a grad dress or something. The cost of making a dress is going to be $3.50 per yard, okay, of material. So we'll say times M, which is yards of material, plus a $100 fee for labor. Okay? So this is, notice what I just did here. I wrote a description for how much a grad dress costs by stating the cost, right here, for every meter that is used in material, and then plus a standard constant $100 for labor. Now, you wouldn't see this. It would be maybe labor per hour or something, but we're going to make a simple equation here. So if we have, 1 meter of material, which you wouldn't, but if you did, how much would this cost? Well, it would be $3.50 times 1 plus 100, $103.50. If you had 10 meters of material, which is a little bit more likely, then it would cost 100 and what? Well, what would this be? Ooh, 350 times 100 is 350. So it's 100 plus 350. That's 450 it would cost. Okay, so you got that? Now, the main point is, back to my main point, okay, that's how you can take a look at some mathematical statement there and interpret it. But let's say I want to write this in function notation, knowing that C is a function of M. C is a function of M. This is what it looks like. C bracket M. This stays the same, but this cost is now a function of M, so you can use really any letter you want there, but you want to keep it the same, C probably. So C is a function of the amount of material used. The cost depends upon, now this is really important, the cost depends upon the amount of material used. That's what we're saying here with function notation. The cost is dependent upon the amount of material used. So which one do we start with? Well, the cost is determined by starting with how much material you used. You find out how much material you used, then you calculate the cost. Domain, right here. Range, right here, cost. Got that? Domain, range, input, output. All right, and then of course you can go backwards too if you want to write this just in 2 variables, then you write this one, C and M. Function notation, 2 variable notation. Okay, so that's the lesson there on that's the introduction to functions, properties of functions. I know that's a lot, but please review the video, watch it over as many times as you want, and go through the notes. Here is the assignment that is associated with this. There's 2 parts to it. Part 1 is what I assigned first day. Part 2 is going to be for day 2. Okay, hope you learned something here.